Welcome to notes 11.1 and 2. Today we're going to be talking about areas of triangles and parallelograms. And we've got some postulates and theorems going on here, which is a little weird because we've never really thought about the area of a square as a postulate. However, the area of a square postulate states that the area of a square is the square of the length of its side. If I were to write that as a formula, obviously I would simply write a equals s squared, with s being the length of the side. The area of a rectangle theorem is that the area of a rectangle is the product of its base and its height. In other words, a equals bh. The area of a parallelogram also states that the area of a parallelogram is the product of a base and its corresponding height. So a equals bh again. Now, height means something a little bit different in a parallelogram than it does in a rectangle, although rectangles are parallelograms. So let's draw a parallelogram really fast. All right, so there's my parallelogram, but the height, remember, height is always, the distance between 2 points is always the perpendicular distance. So in this case, this is my base still, but this, the red, is my height. It is the perpendicular distance between the two bases. All right, and then my area of a triangle theorem simply states that the area of a triangle is 1/2 the product of a base and its corresponding height. Area equals 1/2 base times height. Some of you also like to write it like this, base times height divided by 2, same thing. All right, so these are things you all already knew, but I'm just pointing out that they are either postulates or theorems. But you'll remember, of course, that base times height divided by 2 is not the only way to find the area of a triangle. You can also use Heron's formula if you know all the sides. Right? And we simply add up all the sides, divide by 2, that gives us s, and then we use s in this formula with the 3 sides to find the area of the triangle. Or if we know 2 sides and the included angle, then we can use the side angle side area formula, in which area is 1/2 the product of the 2 sides times the sine of the included angle. Right? So those are other ways to find the area of a triangle. All right, let's solve some problems. So we've got a right triangle here, and we need to figure out what method we need to use to find the area. Well, if we have a right triangle and we know 2 of the sides, then we should always use the Pythagorean theorem to find the 3rd side, especially because we are told to leave answers in simplest radical form. All right, so x squared plus 7 squared equals 11 squared. So x squared equals, let me see, 121 minus 49 would get me 72. Take the square root of both sides, and I wind up with x equaling 6 radical 2. All right, so x is 6 radical 2 meters. Then, since we now know a base and a height, because those are always perpendicular to each other, we just go ahead and solve. So 6 radical 2 times 7 divided by 2. 6 divided by 2 is 3. 3 times 7 is 21, so I get 21 radical 2 meters squared. Pretty straightforward. Moving over to our next triangle, we know all 3 sides of the triangle, but that's it, which means that we need to use Heron's formula. So first we need to figure out what s is. So to find s, we add up all the sides. So 5 plus 11 plus 13, and divide by 2, which means that s is 29/2. All right, so that gives us s. Now we need to go ahead and apply the formula. So k equals the square root of its s, and then s minus each of the sides. So 29/2 minus 5, 29/2 minus 11, and 29/2 minus 13. Now, you might be wondering why I'm not doing this in decimal form, and it's because of this. If I'm going to leave the answers in simplest radical form, then fractions are an easier way to work. All right, let's go ahead and let's just plug all of this into our calculator. when I do that, I get the square root of 7714 over 16. All right, so let's see if we can simplify this. It's really easy to simplify the denominator, right? Square root of 16 is 4, so we've got that. Can I reduce this fraction? Well, this, not reduce fraction, can I reduce this radical? 7714, we could do the whole factor tree thing, right? And we could go about it this way. But if you think about where it came from, it really came from these factors. And let's talk for a moment about fractions, because I have a feeling that you guys have never really warmed to fractions. All right, let's put this into, let me give myself some more space. Let's put this into fraction form, shall we? Yes, we shall, because I'm the boss. All right, so we've got k here, and it equals, and we've got 29 halves. Okay, so in order to actually do this in fraction form, we have to put this into, make a common denominator, right? In order to subtract, you have to have a common denominator. So we need to put this over 2. So we really have 29 halves minus 10 halves, because that's what negative 5 is as a fraction, and 29 halves minus 22 halves, and 29 halves minus 26 halves. So what we really have is 29 times 29 minus 10 is 19, times 29 minus 22 is 7, times 3, and all of that is over our 16 that we get on the bottom, right? Because we get 2 times 2 times 2 times 2, so that's where 16 from. So these are the factors of 7714, and all of these are prime numbers, right? None of them have factors. I can't think of anything that multiplies together to give me 19 other than 19 and 1. Same thing with 29. So these are all the prime factors, which means that if all of the factors are prime and none of them are repeated, we can't simplify that fraction. So this is as good as it gets. That is in simplified radical form, even though it doesn't look that simplified. Moving on to question number 3 here. We have to figure out what the base of this triangle is given the area. This is pretty straightforward. I would like you to solve this problem for me and come back and check your answer when you're done. So hit pause now. All right, you should have set up your problem something like this, and you should have gotten 12 feet for your answer. Okay, let's talk about this guy. Now, this is an equilateral triangle, which means all 4 sides, woo, rough day. All 3 sides are equal to 4, and we need to figure out how to solve this problem. Now, there's a couple of different options here. Since we know all 3 sides, we could use Heron's formula. You just have to remember to put it into simplest radical form, because if you can solve a problem and get an answer in simplest radical form, you must solve a problem and get the answer in simplest radical form, right? I'm going to write that down because this is going to be critically important to the rest of geometry. If can be done with radicals, must be done with radicals. All right, so that means that even though we know that the measure of this is 60 degrees, and you could technically use the side angle side theorem, unless you're going to get a simplified radical for this, you're not allowed to do that. All right, so always pick the method that's going to get you a simplified radical. And personally, although Heron's formula is lovely, I like to drop an altitude, and I like to find the height using the fact that this is a 30, 60, 90 right triangle. So if this is 2 and this is 4, then this is 2 radical 3. And that means my base is 4, my height is 2 radical 3. So my area is my base times my height divided by 2, which means that my area is 4 radical 3 meters squared. I just want to point out that in my answers here, I included my units. If your answers do not include your units on quizzes and tests, you will lose points. So don't get sloppy. Always be sure to put your units in your answer. Okay, so we got triangle here. We know 2 of the sides, and we know the included angle, which means how are we going to solve this one? Yes, by side angle side area formula, which means that my area is going to equal 1/2 the product of the 2 sides, so 5 times 8 times the sine of the included angle. So because this is the case, obviously we won't be able to solve this one using simplest radical form. This one is going to result in a fraction. So please type that into your calculator and get me an answer. And you should have gotten about 15.8 meters squared. All right, moving on to question 6. So here we are given the area is 54 meters, and we're given the altitude is 6, and this side edge is 7, and we're looking for the base. And we know that in a parallelogram, area equals base times height. So the only question here is, what do I use for the height? Do I use 6 or do I use 7? If you shouted out 6, then you are correct. So my area equals 6x, so really that's 54 that equals 6x, which means that x has to equal 9 meters. Okay, base and height are always perpendicular to each other. When faced with an irregular figure like the one in number 7, you usually want to chop it up into some pieces that you can then solve for, things that you know how to find the area of. So for example, you could draw a dashed line right here and make this one rectangle and this another rectangle and then just add the 2 of them together. You could alternatively complete the rectangle and find the area of the big rectangle and subtract the area of the small rectangle. Or you could even draw your dotted line here and do this rectangle plus this rectangle. Totally up to you. But me personally, I am a big fan of the red dashed line. I don't know why, just the way my brain works. So let's find the area of these 2 rectangles right here. All right, well this one is 6 by 12, so that is 72 meters. That's pretty straightforward. Now this one is 4 by something. Well, if this whole side is 10 and this part of it is 6, then this part of it must be 4. So we actually have a square, which means we have 16 meters going on here. And that means my area is 88. Sorry, these should be meters squared. Meters squared. All right. Question number 8, my favorite in this whole chapter. You are going to see this question again and again and again. And some of you, I'm going to put a star on it. Some of you are going to have no problem with this whatsoever, and others of you will struggle, and you shouldn't because it is not hard. I need to know what x is. X is the height of this parallelogram right here. If this is a parallelogram and this base is 12, then this is also 12, right? Because both pairs of opposite sides are congruent. Which means that if I knew what the area of this parallelogram was, then I would be able to find the height. Well, luckily for me, I do know what the area of this parallelogram is because I can use this base and this height to find the area of this parallelogram. The base doesn't just have to be the one that's parallel to the ground. It could be the other side. As long as I have a side and an altitude that is perpendicular to it, I have a base and a height, which means that the area of this guy is 8 times 9, which is 72 meters squared. So now that I know what the area of this parallelogram is, I can just solve for x, which means that that 72 meters squared is equal to 12 times x, which means that x is 6 meters. Be sure you understand how this problem works because you are going to see it again. Let's talk trapezoids. It's a trap. Bonus points if you know where that quote came from. All right, so parts of a trapezoid. We've got base 1 and base 2. Does not matter which one you label 1 and 2. You just need to know that the bases are the parallel sides. And then we've got legs. We should all remember that from our quadrilaterals unit. All right, so things to keep in mind. The bases are always the parallel sides, even if they are not on the bottom. Okay, sometimes we draw our trapezoid sideways. It always confuses students. They don't recognize that they're trapezoids when they're drawn 90 degrees from how they normally are, but they are. Now, if we had two identical trapezoids placed right next to each other, but flipped, what do we get? Well, we get a parallelogram, right? We've got two pairs of parallel sides. And the formula for area of a parallelogram is base times height. Now, looking at this particular parallelogram that we've drawn right here, the base is going to be these two added together, base 1 plus base 2. The height of the parallelogram, the distance between the bases, is h, okay, which means that if I were to try to find the area of that parallelogram right here, I would do my base, which is base 1 plus base 2, times my height. But because I've got two trapezoids stuck together to make the parallelogram, if I wanted to find the area of just one of them, then I would do half that. So I would do 1/2 of base 1 plus base 2 times the height. And we have just derived the formula for area of a trapezoid. The height must always be perpendicular to the base. Just keep that in mind. All right, so now we have some problems. Once again, we're looking for radical form in our answers. Okay, so this asks, what is the perimeter of the isosceles trapezoid to the right? Okay, how do we find the perimeter of anything? Add up all the sides. So we just basically need to know what the legs of this trapezoid are. Well, if this is a right triangle, and it is, because the height is always perpendicular to the base, and this is 5 and this is 12, then my Pythagorean triple tells me that this is 13, which means that this is also 13. So now I just need to know the length of this base. Well, if I drop another altitude over here, I have formed a rectangle, which means that this side is also 10, and this height is also 12. And if this is 13 and this is 12, then this must be 5. So this base down here must measure 20. And now I just add up all the sides. 10 plus 13 plus 20 plus 13. And I get 30, 43, 53, 56. 56 units, whatever those units are. All right, now let's talk baseball diamond. A baseball diamond is 90 feet on a side, which means it's a rhombus. The question is it also a square? And the answer is yes, it is a square. All right, so we need to find the distance from third base to first base. So let's draw our baseball diamond. It's a tiny little baseball diamond. Make that bigger. Let me rotate it so it's in the form we're used to. All right, so there's our baseball diamond. For those of you who are sports challenged, which I'm sure does not describe anybody in a pre-AP class, we've got third base over here, and we've got first base over here. This would be home, and this would be second. All right, so we need to know this distance right here. And we know that it is 90 feet on the side. Okay, so if this is a right angle, what is the measure of this? If you said 90 radical 2 feet, then you are correct. That is the distance from third base to first base. All right, let's see. Question number 3 says, what is the altitude of the trapezoid to the right? Well, let's draw the altitude, see if that helps. So there's an altitude, and it is perpendicular. All right, so let's draw two altitudes for funsies. There's my second altitude. Okay, if this is 25, then this section right here is now 25, this part right here, which means that I have 10 left over out of my 35, which means each of these is 5. So I need you right now to take this right triangle and find for me the altitude of the trapezoid. Come back when you have an answer. Hit pause now. And you should have gotten 10 radical 6 units. If you have questions about that, be sure to ask in class. All right, and then we need to find x in this lovely little triangle. It's this little piece right here, which means that what I really need to know is I need to know what the whole side is. And since I have a right triangle, I should be able to do that. And then I need to know what this piece is. And I need to know what this piece is. And I need to add these two together and subtract them from the whole to find this one. I am going to ask you for the answer to this in the notes check, so be sure to solve this problem. Let's learn a couple more formulas that we need to memorize. For both the area of a rhombus and the area of a kite, so anything that has diagonals that meet at a perpendicular, okay, because both a rhombus and a kite have diagonals that meet at a perpendicular, the area is going to be 1/2 the product of those diagonals. So in this rhombus right here, we've got the product of those two diagonals, and in this rhombus right here, I'm sorry, this kite right here, we have the product of those two diagonals. Okay, so if the diagonals meet at a perpendicular, the product is, I'm sorry, the area is 1/2 the product of those diagonals. Make sure you memorize this formula. For some reason, it gives kids a tough time. Really not that hard. Okay, moving on. We've got an isosceles trapezoidal fence with given dimensions placed around an area. We need to find the exact and approximate area enclosed by the fence and the exact and approximate perimeter of the fence. All right, let's draw a picture, shall we? Okay, so we've got trapezoid A, B, C, D, and A, B. Oops, A, B is the long one, and that is 16, and CD is the short one, and that is 8, and the measure of angle A is 60. Okay, and we need to find isosceles. All right, I would like you to find for me the exact and approximate area enclosed by the fence and the exact and approximate perimeter. And I'm going to ask you for one of each of those in the notes check. Remember the difference between exact and approximate, right? Exact, you do not round, and approximate, of course, then therefore you round. All right, so be sure to work this problem and give me the answer in the notes check. All right, I would also like you to find for me the area of this rhombus in the notes check. Now, the fact that this 11 is pointing to this right here means that this is also 11, which means the whole diagonal is 22. And then furthermore, if this is 8, this is 8, so this whole diagonal is 16. Give me the answer in the notes check. Super easy. All right, let's talk about this one. One diagonal of a kite is 2 times as long as the other diagonal. The area is 56.25. What are the lengths of the diagonal? Well, if we say that the length of diagonal 1 is x, then the length of diagonal 2 would be 2x. So my area is going to equal 1/2 of 2x times x, which means that when I simplify it, 1/2 times 2 is 1. I get x squared. So I simply take the square root of both sides, and I get that x equals 7.5 feet, which means that my diagonal 1 is 7.5 feet, and my diagonal 2 is 15 feet. I would like you to solve this one for your notes check, basically using the same method. All right, one more problem. So we have to find the area of a rhombus with vertices at these locations. And I don't exactly have graph paper here. So let's go ahead and remind ourselves what the area of a rhombus is first off. And the area of a rhombus is 1/2 d1 d2. Well, in this case, if I draw a really quick rhombus, so really quick, ooh, terrible rhombus. Get that guy out of the way. All right, ooh, he bounced, that was fun. Okay, so remember that for rhombuses, we just need to label them either clockwise or counterclockwise. Okay. The reason why I'm doing this is I want to remind myself which ones are my vertical or my diagonals. So NQ is a diagonal and MP is a diagonal. So if I were to write this as an expression, I would write 1/2 NQ MP. Okay, so that's this diagonal written as that. So what I really need to know is I need to know the distance from M to P and the distance from N to Q. Now, fortunately for me, these two have the same Y value, which means that this is a horizontal line. So the distance between these two is simply the distance from 1 to 7, so that distance is 6. You see, that was my MP. So that distance is 6. And then these two have the same X value. So this is a vertical line. And that means the distance is from 5 to 1, which is 4. So my area of this rhombus is 1/2 of 4 times 6, which is 12 units squared. As straightforward as that. All right, this concludes the notes. Please go on and do the notes check. And if you have any questions, be sure you ask in class. Thanks.